architectural philosophy was mainly led by the relation between the interior and exterior, how the building was affected by its surroundings and how it affects its surroundings in turn. Throughout the process, the concept was developed with a strong emphasis on collaboration to achieve structural and sustainable needs in line with the input from the other teams within Integro Associates.
The site analysis the architectural team conducted primarily has a major impact on the design process. As the shape of the building took form, it was molded to integrate with existing building heights, green spaces, car parking and access, taking into account the primary access route on the building and focusing on the circulation on the site. Pedestrian access was concentrated around the front main facade, while the vehicle access was provided towards the rear, allowing supply of materials and parking spaces.
The main facade to the west side of the building was primarily glazed to increase sustainability ratings through captured solar gain, controlled by interior solar shading. Trees give natural shading to prevent glare within the internal environment during the summer months, yet to offer a reduced level of shading during the winter. Included in the building design is the capability for building users to open windows, allowing for controlled natural ventilation.
The shape of the building was mainly focused on the functionality and permeability throughout the building. From the western facade, the spaces are developed to make a transition from public to private spaces the further you travel into the building.
Additionally, each functional space was considered in terms of its required open space area. Rooms were assigned to the new or old construction, depending on the limitations of the old and proposed structure. Key areas that were placed to avoid structural conflictions were the computer rooms and the architectural and architectural technology studios.
The shape of the building determined the breaking up of dedicated type of spaces which were kept distinct but well suited in relation to each other. To give a sense of relation between the outside and inside environments, these spaces were connected through spacious corridors with sitting and communal areas, giving an airy and open ambience.
The white concrete exterior cladding combined with curtain wall glazing was chosen as a representation of the modernistic approach with which Coventry University presents itself as an institute of learning. The central section of the existing building portrays the continued development of the engineering department within the building, contrasted with the irregular form of the outer segments that illustrate the artistic activities within the architectural field.
The new structure is designed in a uniform layout, with the majority of beams and columns placed in a grid design sympathetic to the existing structure, whilst also increasing open space areas, especially in the extension levels.
A pre-assessment has been done on the BREEAM official website, and a report was issued concluding that the implementation of all the above design options will achieve a very good rating.
The structure is built out of steel for quick erection, higher quality control and aesthetic purposes. It has larger spans, thus allowing the creation of large open spaces. It also fits well with the exterior of concrete and glazed facade.
The priority in building material selection is to minimize waste and carbon output, as construction materials have a profound negative impact on sustainability. Whilst it might seem counterintuitive, the building should also be designed with its own demolition in mind, ensuring that its materials can be reclaimed once it has reached its end of life. Therefore, we decided for the steel structure, as it comes with a smaller carbon output than concrete, is 100% recyclable, and it achieves BREEAM waste credit.
A large part of working to the BIM philosophy is that as a company we work collaboratively together. This helps us to produce better designs in less time. It also means design issues are brought up sooner, as all teams are looking at the design through all stages.
After carrying out a structural analysis on the existing Sir John Laing building, it has been found that there is little of the bearing capacity remaining in the columns. This is as little as 15% in some cases. The new structure is completely freestanding, thus ensuring no additional loading is placed upon the existing columns. Moreover, measures will be taken to ensure that the existing structure will remain structurally sound during and after construction. To make the new structure freestanding, a truss system will be installed. The truss system will span across the width of the existing structure, taking all imposed loading from the extension. The truss will be attached to separate freestanding columns either side of the exterior of the building, transferring the load down into deep plywood foundations.
The new foundations for the John Laing extension are all monopiled, with only 2 different diameters. This means they are easy to install, cost effective, reduced in noise pollution, and the least environmentally damaging to surrounding ecosystems.
Composite flooring has been used to maximise the best properties of two materials, steel and concrete. Hence it produces an economical, fast and simple flooring design. This has also been used for the roofing scheme.
Grassland living roofs, which involve the use of limestone chippings and mixtures of crushed brick and concrete, can support as many as 30 species per square meter, so even a small surface will potentially be home to many different plants. Green roof also acts as thermal insulation and contributes to the reduction of surface water runoff. It is cheaper than conventional roof insulation technologies and extends 2-3 times the life of the roof. Most green roofs will require maintenance only once a year.
All concrete in the structure is cast in situ to make the concrete homogeneous. Spray concrete will be used for the external white facade.
Although it will be mainly a steel structure, the high mass of the composite flooring will provide a significant thermal reservoir with the capacity to store large amounts of energy. In cold weather, floors absorb and store interior heat during the day, then radiate warmth back into the conditioned space at night. Conversely, when the outside temperatures are high, the same principle holds true for cooling. The inherent ability of concrete to maintain a steady interior temperature reduces peak demand on cooling equipment. This, combined with the reduced volume of steel structure, will allow the installation of smaller, less costly HVAC equipment.
To help ensure the durability and robustness of the structure, the new columns have been designed with an allowance in the redundant bearing capacity. This will help prevent progressive collapse in the case of accidental damage. Furthermore, an additional benefit of having redundant bearing capacity in the beams and columns is that it allows for a greater flexibility in the use of the building in the future, as well as an additional expansion and further development of the green roof.
A steel frame is weak to lateral forces or wind. In order to enhance stability within the structure and account for this, the design has 2 steel shear cores around the lift shafts. Additional bracing members are placed on the north, south and west sides of the structure to transfer the lateral wind loads into the ground.
Fire protection regulations are met throughout the building by using intumescent coating, which gives 120 minutes of resistance. External members will be protected from corrosion by hot dip galvanising with a sacrificial metal to ensure a long-term design life and a reduced maintenance schedule at handover, whereas internal columns will be encased for added protection and to fit with the architectural aesthetic scheme.
Solar control glass is a high-performance coated product that allows sunlight in while repelling solar heat. This technology is beneficial in hot summer days when it can help to reduce the load on the building's air conditioning system, thus reducing the energy demand. In addition, solar control glazing comes in double glazed units, which also provides insulation in winter. Solar control and low emissivity properties are combined into a high-performance glazing unit, thus further contributing to insulation from both cold and heat depending on the season. The large glazed areas will also allow daylight to enter into the building, therefore reducing the need for artificial lighting. Thanks to these properties of double glazing, we can now incorporate large areas of glazing into the John Laing design, knowing there will not be any negative impacts on the energy performance of the building. Implementing renewable energy technologies can be very expensive and may not be applicable for the John Laing building, but one of the most effective ways we can reduce the building carbon emissions and achieve the BREEAM credits available for this category is through changing the source of its power supply. This can be done very simply by just switching the electricity supply to a company which is fully committed to renewables. It requires no initial investment and doesn't take more than 3 weeks. Flood risk, surface water runoff and pollution are among the most highly legislated and monitored areas of planning and construction. Surface water management is one of the mandatory areas in the BREEAM assessment, and the use of permeable block paving achieves an A or an A+ rating in the BRE Green Guide, gaining BREEAM credits. Therefore, the surface of the John Laing parking area and the adjacent pedestrian pathways will be replaced with permeable paving, creating a modern-looking surface and will contribute to attenuation of the urban flood risk.
We will continue to analyse and evolve the BIM model, using Calibre Design Checker to carry out regular clash detection and other analysis of our design, saving a lot of time by effectively cutting out issues which may otherwise arise during construction. The BIM model will also allow further disciplines such as M&E to add their models for further collaboration and checking.
One of the key features of the method statement is the spray concrete on the external face, which is innovative to the design. Further, lots of consultation with stakeholders is planned to minimise disruption and make them fully informed about the work plans and programme. Health and safety is key for Integro associates, which implement the Don't Walk By policy to ensure everyone who enters the site goes home safely to their loved ones.
Using Celebri, we can provide data takeoffs and Kobe drops, allowing for 4 or 5D BIM coordination. This will help massively with scheduling the construction and will hopefully help to reduce the actual time taken for construction. It will also help with pricing the project as all components are listed and detailed. At handover, we are able to issue the client with a 3D as-built model containing all data. This will help with future maintenance as it provides an easy access record of what exactly has been built, with full component details down to the specification of a single light fitting. The data in the model will also be extremely useful for future modifications to the building. Next year it will become mandatory for all public building projects to be completed to BIM Level 2, which is a managed 3D environment. Although this project is privately funded, BIM is the future, and Integro associates believe this project provides the perfect opportunity to cultivate this vision.